Hi, my name is Karenna Johnson. I am a current sophomore studying economics and Chinese here at the UO, and I was a first year research experience award recipient for the summer of 2025. I did my research in the Brain and Memory Lab in the Cognitive Psychology department, and I'm excited to share some of my research results and some of the process with you all. So, my work was on false memory's relationship with working memory capacity. So, in this presentation, I'm going to introduce and define the different memory types that I was interested in studying. I will go a little deeper dive into the different tasks that we used, and then lastly, I'll go over some results. First off, working memory. So, working memory is defined as memory that holds information for a shorter amount of time, is often used for a certain type of task. So, for like some examples, say you're at a coffee shop or a restaurant and there's a pin pad code on the bathroom. And so you walk up and you ask the barista, you're like, oh, what's the code? And they say it to you, and it's a string of four numbers, and you have to remember it. And for some odd reason, this is always very challenging for me. And then once you get to the bathroom, you type it in. That's your working memory in action. Another example of this is you set your keys down somewhere kind of unusual, and luckily you remember where you put them. I think this is another thing that happens to me kind of often. I'll forget something in my room and leave my keys on a weird table in my kitchen, and they're always impossible to find. So, in traditional like cognitive psychology lab settings, there are a lot of ways to cue for working memory. Two of the common ways, or maybe the most common way, is the digit span task, um, which is sort of down here on the bottom below my key pictures, which is please remember these numbers 4615. So it's kind of similar to the bathroom code example. In the data sets that I worked with, we used the colored squares task, in which my lab calls K, which is a visual working memory task. It's where six colored squares flash on screen, and participants try to correctly recall as many of these colors as they can. So you see this one's red here, and then after a short break, participants will try to correctly click red for that square. So let's practice it. I'm going to flash some colors on the screen super quickly and see how many you can remember. Great. Take a second, try to remember as many as you can. This task is immensely challenging for me and difficult all around, I would say. So here are the right answers. Um, it can be a quite challenging task. Next, false memory. So, false memory is very easily defined as memory or remembering events that didn't actually occur. So, some examples of this could be thinking that you took your medicine when you actually didn't, um, or incorrectly identifying the perpetrator of a crime in a lineup. So, false memory has huge ramifications, and there's a lot of like studyability here, um, from simple things like did I take my ibuprofen or not to um, picking somebody out of a lineup. False memory has huge effects. And the way that our lab tests for false memory is the Rodinger-McDermott test task, which we call DRM. So, a little bit more about DRM. Well, before I tell you about it, let's practice it. So, you're going to see a string of words. Do your best to remember as many words as you can. Great. Now, take a second, try to recall as many as you can. I think there were about five. Okay, so the words on that list were bed, rest, slumber, nap, and pillow. So if you came up with sleep, or you would have written down sleep if you were doing this test, that would have been an instance of false memory because that word was actually never shown. So, DRM and false memory. Individuals are presented with a list of words with one in common, one common left out word, which we call the critical lure. This is one of our big variables of interest when doing the DRM task. False memory occurs in this task when participants recall the critical lure despite it never being presented. There are also other ways to false alarm or have false memory events in this task. Um, you could come up with a word like chill or something kind of adjacent, which wasn't presented but is still related. That would be called a related lure. And then you people also come up with totally unrelated words like cat, and that would be specified as an unrelated lure. So in this example, sleep would be an instance of false memory. So, to go over the results and a little bit about the structure of the study that I did, I worked on a couple different things throughout the summer, and one of the big ones was this project of taking three data sets existing in my lab and looking at the false memory and working memory capacity relationship across these different data sets. So, I was super lucky that these different sort of long form studies that were done in my lab throughout the past few years had the same tasks. So I was able to sort of look at the correlation between these two and three like pretty large data sets and to see if there are consistent results. So I worked through these three different data sets correlating these working memory capacity numbers and the false memory events and different measures related to that. So the main result was we found that working memory capacity is significantly correlated with the ability to correctly recall words in the list. However, it is not significantly correlated with false memory events. And to go over some of these measures of interest, we have K-score, which is the number of correctly identified colored squares. So that's our working memory task score. Next, we have DRM hit rate. It's the number of correctly recalled words. Next, DRM false alarm to critical lures is the number of times critical lures were recalled. And then DRM total false alarm is the number of total false alarm events. So that's going to be critical lures plus related lures. We leave out unrelated here. And then lastly, DRM corrected hit rate. It's a metric of a hit rate minus false alarm rate. So this is the big matrix that I made over the summer and throughout my time doing this data analysis. We'll break it down piece by piece. So data set one. So an important note about this data set was the DRM was a little bit different. And the DRM version that I sort of showed you, it had recall of the words shown in the list. The data set number one used recognition. So this added some funky things to the results. So for recognition with DRM, you would be presented with the word list the exact same way. However, instead of recalling the words, you would be asked if you had seen the word or not. So here with our working memory score and the different DRM measures, we find that nothing here is really significant and nothing is really extremely correlated. A lot of these lines are pretty horizontal. So nothing super significant was found in this data set. Next for data set two, this one went back to recall-based DRM, so more similar to the version that I showed you, and also similar to data set number three. Here we're looking at hit rate, DRM hit rate, and working memory score was very significant and pretty, the effect size was decent. So this was significant, and then also this corrected hit rate. So it's important to note here because the corrected hit rate is a metric of the hit rate minus the false alarms, and the false alarms neither of which the critical was not significant. It's important to note it was largely driven by the fact that the hit rate was significant. And the fact that hit rate and working memory score are correlated and significant makes pretty intuitive sense. If your working memory capacity is higher, it would seem kind of intuitive that you could remember more of the words on the list. And we found a very similar trend here in the third data set. This data set was fun to work with because I actually got to help run some of the participants within this study. So it was fun to do some analysis on it later in the summer. So again, here we found a similar relationship between hit rate and working memory score. Similar across the board between data set number two, and that is to be expected because the tasks were so similar. Actually, they were the same, and the population was largely similar as well. So putting this matrix all together, you can see here the different, sorry. You can see here the different tasks or the different data sets and their relationship with each of these measures of interest. So again, working memory scores here on the vertical and the horizontal are different working memory score measures. So very interesting, super fun analysis to do. Now for future work. This was sort of a project that I also got to run in conjunction over spring term, and I got to do some analysis over the summer. We ran some pilot data. However, we're continuing to run this different study that uses working memory and false memory and to see the correlation between the two. So in this task, we're actively manipulating working memory capacity to see if it causes more false alarms or more false memory events. We have three different conditions. One is the control condition, and then we have a condition that places the word list first, and one that places our working memory digit span task first. So a reminder about digit span, it's similar to that bathroom code example. Um, it's going to be a string of numbers, and participants will be asked to recall those numbers. And then DRM is similar to the one that I ran through with you. Participants will be shown a list of words and then later asked to recall as many of those words as they can. So the different conditions here, and then also across with that control, we're manipulating the working memory capacity a little bit differently, and we're also placing emphasis on different areas. So the control helps us understand how the performance on these tasks when they're separate. And then the conditions that intermix the two, we found that the participants kind of place favor on which one they were presented with first. So yeah, I'm excited to see what the results on this will be. That's it for me. I want to say a big thank you to the Cure team, to my mentor and my biggest help, Shayna, and my PI, Dasha, and everyone at the Cure team. Again, this was an awesome experience, and thanks for watching.